Welcome back to Stat 400 from the University of Bridgeport, part 2 of week 2. So in this week, again, we're going to expand on descriptive statistics, and we will also be creating some histograms. So first things first, I will be setting my work directory. It's just a place on my computer where I will be saving things to. I like creating my work directory. We'll be installing this new package called fbasics. Take note as to how it's spelled. Lowercase f and basics starting with a capital B. Okay? I've already installed it, so no need for me to reinstall it. However, all this code is going to be available for you on the course website. So I'm going to be calling my ISLR library as well as fbasics. Have them both loaded. Again, I can see my packages here again. So make sure no reason to believe that it wouldn't be loaded. But here we have fbasics and the ISLR. Here we are. So in my example, I'm using the OJ data. You guys are using the car seats data for your assignments. But back to the OJ data, call up that data. I am going to run now the basic stats on OJ. I will have an assignment that I just want the certain variables I need the basic statistics on. The skewness, kurtosis, variance, standard deviation, etc. So I'm going to run basic stats. This is the command that you need to get all these skewness and kurtosis, standard deviation, so forth. So I'm going to run this. When I run it, it's saying, oh, error, non-numeric argument to binary operator. So let me see what's going on here. So again, if I go to my OJ data, I actually see that there is some non-numeric data within the data. Also, in my hypothetical assignment, I don't need it. All these basic statistics of all these variables. I just need it on a few. So, as we learned in the previous video, if we just want to run the basic stats on one variable, I call up the table, the data frame name, $, and then the variable. So let's run this, see what happens. Oh, no error. Why? Because price change is a continuous variable. Let's observe what do we have here. We have as an output number of observation, NAs meaning null values, the minimum, the maximum, quartiles, mean, median, sum, standard error of the mean, lower control limit, upper control limit. These are 95 confidence intervals. We haven't seen them yet, don't worry. Variance, standard deviation, skewness, and kurtosis. Here we have our values. Just what we needed. So the problem is that there are categorical variables in the data. Again, we can see that if I do stroj, again, we have the structure. So when I see num, this I can do the basic stats on. When I see factor, I can't do it on that. Okay, here we have another factor. Okay. So basically, I know that variables 1 and 14 are the ones that I don't need. Okay, so I can actually do this. I'm going to create a new data frame called OJ, but lowercase. And this is my code. Using the data frame OJ, give me all the rows, meaning blank, comma. So this is rows, comma, columns. So I want all the rows, no constraints on the rows. The columns, I want all the columns, okay? The C doesn't mean columns. C means is combine. -1, -14. -1 says minus variable 1 minus variable 14. And what I get here is I get, instead of 18 variables, I have 16. I can do my basic stats on OJ, and it runs perfectly. I have it on 16 variables, all continuous. Now, answer the questions from my sample assignment that we'll see in the next video. I just want the summary statistics for price difference, price change, sales price, of Citrus Hill, sale price of Minute Maid, discount of Citrus Hill, discount of Minute Maid. So again, I can run this code over here. Basic stats for price difference, basic stats for price change, sale of price of, Citrus Hill, sale price of Minute Maid, etc. So I can do this one by one and it'll run. So here we go. Run it for one, the next one, the next one, the next one, the next one. Oh. This didn't run because it doesn't know what it is, obviously. So there's no variable called C. Now, or what I can do more interestingly is that if I just want it on these 5 variables, I can create a new table, a new data frame called temp. I can name it whatever I want. I'm going to base it on OJ or on capital OJ, doesn't matter. They all have the same, these variables that I need. So again, I want square brackets, okay, all the rows, comma, the columns that I do want, there's no minus sign, is by name. So again, the C here is for C as in combine, open paren, and in quotation marks, write the name of the variables that you want. If I do this, boom, I have a table called temp, or a data frame called temp, with some 5 variables, the 5 variables that I want. Now I can do basic stats on temp, and now I get them all together. You can copy this and paste it then in Excel to create your table. The only thing, it's going to create all of this in one row. So then you're going to have to go to a function within Excel, which is data, text to columns, and it'll break it out into columns. Okay? Or if not, you can do a copy of a screenshot of just this piece, put it on your assignment, and there you have, again, everything that you'll be asked for. And again, variance, standard deviation, skewness, and kurtosis. So this is great. Okay, now let's create a histogram. A little note on histograms is that I am using a Mac. I have seen sometimes that if you're using a Windows operating system, you may need to write, instead of hist as in HIST, you may need to write histogram. Okay? Histogram will not work on a Mac, so you use hist. Okay, let me just do a quick save here. Okay, so this will create a histogram for the variable price diff. This over here that says main equal, and then I say price diff minus ch. Main, what main is the title of the graph. So here we go. Boom, here I have a nice little graph. Here's my histogram of price difference. Let's take a quick look here. So here I have my summary statistics of price diff. It said it is negatively skewed slightly. It's a negative number. It's 0.75. It's not very skewed, but here we see that negative skew. How about kurtosis? It is above 0.45. You can see the peakness over here. Okay? Okay. So here we have histograms. We can create one for each one. I want to show one with positive kurtosis and a lot bigger skewness. So it would be this one over here. Let's run it. Here you see positively skewed. This is discount Citrus Hill. Sorry, discount Citrus Hill. You see the skewness is positive. You also see the kurtosis is a lot bigger. Very peaked, and it's peaked right over here. So again, positively skewed, high kurtosis. So this is the visual part where you can actually visualize what these metrics are saying to you. Okay, this is all you really need to be able to do your assignment, but it's nice to go above and beyond. So let's say I don't want to create just, again, this, if you want to export it, all you have to do, you can actually just, again, click zoom if you like. You can examine it, so forth. You can do copy image and then paste it somewhere else. That's fine. You can do many other things. You can hit the export as image, export as PDF. You can export this graph and get it into your presentation for your assignment. However, doing this one by one could be painful. This little function over here is saying I want to create a bunch of graphs, 2 rows, 3 columns. Again, I have 5 graphs here. So if I do 2 rows and 3 columns, that gives me 6 boxes. Well, 1 box will be empty. So let's run this code. Doesn't do anything. But then I'm going to run all my histograms. Sorry. I'm going to run them all. And look what I get. I get all 5 histograms in one place. Now, if I click the zoom, I can see it here. Sorry, let me get this into the screen. And I can actually fool around with this a little bit, and the histograms will adjust. Now, this is actually something a lot more interesting for me to just do copy image and paste it onto my deck for my assignment. One thing to remember to do is to revert back to the original of just one by one. So when you do another graph, it won't just paste it in here. Okay. Now, what happens, again, going way, way, way above and beyond, is that I'd like to plot in the mean and the median into my histogram. So let's take a look at what this code does. There we go. Now let's do this in steps. It has, first I run this, which is my histogram. Then add line V as in vertical equal to the mean of price diff. This is what I'm doing, the histogram of price diff. So let's get the mean in there. And the color is going to be royal blue, and this is kind of the thickness of the line. All you really need to change is, for your assignments, is what data frame and the variable that you're going to be doing it on. So now let's do, this is the mean. Here we have the mean now plotted. I know that this is positively skewed, so that means that the mean, negatively skewed, that means that the mean should be smaller than the median. Let's see if that's right. So here I'm going to put in the mean, and I'm going to make it red. So let's run this. Oh, no, I was wrong. So here we have the median. I was wrong. The median is above the mean here. Okay? So we can do this for all these graphs. And again, very simply, we can do it. Okay. Now, if we want to put it all together in one big output, here we go. Here I have it. I want to click the zoom button. Yep, this is kind of how I want to export it. So I'm just going to copy image and then paste it into my presentation for my assignment. So next video, we will go into what this assignment is all about and how does it look. And again, remember that my assignment is a sample assignment. Yours is similar, different data, slightly different questions. Again, thank you very much, and now to the next video.